Hello again. Now we are going to consider three reservations. Um, y is still the binomial distribution, binomial random variable that counts the number of cancellations among three reservations. And we have A, B, and C. And still the probability of cancellation is 10% and they are independent. What is the probability that only one of three reservations is cancelled in this case? Remember how we calculated the probability with two reservations, and try it by yourself. Spend some time, think about this, and in particular, you have to think about how many outcomes included in this event. Pause the video and try it by yourself. I will turn to the next page. 3, 2, 1. So now we cannot make 2 by 2 by 2 table in a slide. It's two-dimensional slide. So instead of making a 2 by 2 2 by 2 by 2 table, I just list all the possible combinations. So when you have three reservations, and for each reservation there are two outcomes are possible. So that means 2 by 2 by 2 outcomes are possible. So there are total 8 possible outcomes. So for example, the first line means no reservation is cancelled. And second, A is cancelled but B and C are not. And A is not cancelled, B is cancelled, C is not. And only C is cancelled, and A and B are cancelled. A and C are cancelled, B and C are cancelled. All reservations are cancelled. So there are 8 different combinations of the three binary variables. And among these 8 outcomes, we are interested in the case where only one reservation is cancelled. 3 of the 8 outcomes satisfy the event. So we are interested in these uh, three cases, three combinations. And simply speaking, one reservation is cancelled, and then it could be A, or it could be B, or C. So there are three possible outcomes. Easy to count. And then, if you calculate its probability, the probability that only one reservation is cancelled equals to probability of three outcomes. Sum of the probabilities of three outcomes. And for each outcome, in the first case, A is cancelled, B and C are not. Then cancellation, 0.1, probability of cancellation times 0.9 times 0.9. By the way, in this equality, we are using the statistical independence. So the intersection probability of intersections can be split into multiplication of single probabilities. So cancellation, probability of cancellation is 0.1, probability of non-cancellation is 0.9, probability of non-cancellation is 0.9. And for the second case, non-cancellation, cancellation, non-cancellation, 0.9, 0.1, 0.9 multiplied. And finally, 0, 0, 1, 0.9, 0.9, 0.1 multiplied. And then they are summed because they are different outcomes. So when you calculate a probability of an event, you have to sum the probabilities of the outcomes included in that event. Anyhow, another interesting pattern here is there are three possible outcomes, but each of the outcome has the same probability. 0.1 times 0.9, 0.9. Only the order is changed, which does not matter. So in the end, there are three probabilities, 3 of 0.1 times 0.9 raised to the exponent of 2. So 0.1 times 0.9 times 0.9 are repeated 3 times. Okay, do you get it? If you calculate this, I don't remember what was the answer. I don't remember, maybe this one. So it's not that difficult to do the math. So maybe 24%, I guess. So then what's important here is not the answer, not answering to each question. We would like to extract a general pattern. What's common in between these two examples? So let's think about this. When you have two reservations, the probability of one cancellation was this. There are two of zero point 0.1 times zero point 0.9. And in three reservations case, there are three of 1 time, 0.1 times zero point 0.9 and zero point 0.9. And then we may dissemble these probabilities into two parts. First, the number of outcomes in the event. So we have two and we have three because there are multiple outcomes included in this event, y equals to 1. So y equals to 1 included two possible combinations when there are two reservations, and y equals to 1 included three possible combinations when there are three reservations. So 2 and 3 are the number of combinations that satisfy y equals to 1. And the second part is probability of a single outcome. So in each case, like when you know who canceled, then this is the probability. So for a single combination, the probability is the same no matter who canceled. So we are going to study the latter part first, and then we will come back how uh, how these numbers will change when numbers get more complicated. So now then, let's think about the second part. When you have two reservations, what we had to calculate is probability A equals to 1 and B equals to 0, or A0, B1. What you need is just 1, 1, and the other is 0. A may be 1, B may be 1. And when you have three reservations, the idea is the same. You have 1, 1, and two zeros, right? The 1 could be A or B or C. So there are three different scenarios. Uh, then what you can observe from these probabilities is that first, 0.1 is multiplied as many times as cancellations, because 0.1 is the probability of cancellation. So 0.1 here is coming from A equals 1. A is cancelled, so you are multiplying 10%. And here 0.1 is coming from B, who cancelled in this scenario. So you have 0.1. So 0.1 is multiplied like as many times as cancellations. So probability of cancellations as many times as the number of cancellations. And similarly, 0.9, which is the probability of non-cancellation, the probability of non-cancellation is multiplied as many times as non-cancellations. So 0.9 and 0.9, there are 2.9s multiplied because B equals to 0 and C equals to 0. B did not cancel, C did not cancel. So that's why we multiply 0.9 twice. So probability of non-cancellations is multiplied as many times as it happened. And another important observation is that the probability in the end does not depend on who canceled, right? It only what matters is how many times 0.1 is multiplied and 0.9 is multiplied. You don't need to worry about the order. A may be canceled, but the probability that A cancels but the other is not equals to the probability that B cancels and the other not. So as long as one person cancels, it doesn't matter who is canceling the reservation. Just the probability are the same. Probabilities are the same. So we may, using these observations, we may generalize, we may formulate the second part. in the general setup, think about this. There are n trials, which is the number of reservations in our example, 10, 2 or 3. And P is the probability of success in our example, cancellation. So N and P are given, and we are interested in the probability that the total number of cancellation equals to 1, or it could be a different number. Anyhow, in general, y, small lowercase y. So given these three numbers, n, p, y, we have to calculate the probability. Then what you can see from the pattern we observed in the previous examples is this. Probability of cancellation, P is probability of cancellation, and 1 minus P is probability of non-cancellation. And we are interested in the case where Y number of cancellations happen. So cancellation happens Y times, then automatically N minus Y reservations are not cancelled. So there were N number of reservations, but Y was cancelled. Y of them are cancelled, which means the other N minus Y reservations are not cancelled. So N minus Y have non-cancellations happen. So in general terms, success happens Y times with probability P. So P is multiplied Y times. And failure happens N minus Y times, and its probability is 1 minus P. So 1 minus P is multiplied N minus Y times. So this is what we get in this part. In this part, exactly, remember, when you have two reservations, probability of one cancellation. So cancellation happened once, non-cancellation happened for the other reservation. So 0.9 happened once. When you have three reservations and one of them was cancelled, then cancellation happens once, non-cancellations happened twice for the other two reservations, right? So the second part is perfectly explained and understood, hopefully. So we will, in the next time, we are going to, so we are going to extend the number to 4 reservations. 2 reservations, 3 reservations are now, it's understood, like you are good. But what happens if there are 4th reservation, and then it becomes a little bit more complicated? I think the next video will be uploaded next week. And remember, homework is due every Sunday, and I see that many students are behind the schedule. So then it will be very much difficult to catch up near as as more homeworks are posted. So please do it as soon as possible. And already there are some students who ask me if I can change the due date or change the grade. Of course not. The answer is not. Please keep the due date and work hard. And and also, I am still holding office hours on Tuesday and Thursdays at 10 to 11. 10 to 11, yeah. But I have seen only one student who asked no question. So please, if you have questions, let me know. I I can't believe you have no question. Please utilize me. Okay, see you later and enjoy the weekend. Stay safe.